Hey guys, today we're going to learn about something called half-life. And as you can see right in the name, it says the word half. And so what we're going to be doing today is dividing a lot of things in half. Here's the reason why. Half-life means it's the time for half of the atoms in a radioactive sample to decay. So notice that this says radioactive. And you've heard a lot of times that radioactive things aren't good for us. We do use them in a few situations to help us. And so here's an example. This person has gone to their doctor, and their doctor is trying to figure out if this person has a mass or cancer or something wrong in their body. So the doctor gave this person a small amount of a radioactive sample, and it's okay because it's only a little bit. And then they took a picture of that person, and in all of these areas where you see this white, this glowing, that's where the radioactive sample has really concentrated in a large amount in that person's body. And that means that something is probably wrong in that area. And now the doctor can figure out what to do for that person. But the half-life part of this means that eventually that radioactive sample is going to break down. And so if I took a picture of this person again in a few hours, all of these glowing areas would be gone. Because that sample has a half-life, I wouldn't see it anymore. It would break down, it would decay, it would leave the person's body, and then it won't hurt them, and that's why it's okay to use these little bits. So what we're going to try to do is the math and figure out, well, how long would that take for it to leave that person's body, and how much of that sample would be left there. The cancer or the mass might still be over there for the person, but the radioactive sample is going to be gone, and we want to see how quickly that will happen. So another way to think about this is in terms of M&Ms, because that is my favorite candy. Okay, so say I started on Monday and I had 100 M&Ms, and I always eat half of whatever I have every day. So the easiest way to set this up is in a T-chart. That's going to help us keep track of all this half that we're going to do. And so this column is going to be the time, and this column is going to be the amount of whatever substance you have. In this case, we don't have something actually radioactive, it's M&Ms, which are delicious. Okay? The thing about the time column is it always has to start at 0. Always, always, always. Okay? For us, our 0 day is Monday. That's the beginning of our process. The amount of substance that I have on that day is 100 M&Ms. So I put that into the chart. So after one day, which will be Tuesday, I'm going to eat half of my M&Ms. So if you do 100 divided by 2, on Tuesday I will have 50 M&Ms. So that's the answer to A. At the beginning of the day on Tuesday I will have 50 M&Ms. Now if I go another day, so on day 2, which will be Wednesday, I'm going to eat half of my M&Ms again, and I will have 25. I still have a whole bunch of M&Ms. I'm going to keep eating them. If I let another day go by, that's going to be Thursday. I'm going to divide this in half again, and here's where it's going to get a little tricky. I'm going to have to get like a knife out and cut an M&M in half and eat 12.5, so 12 and a half M&Ms. Hard to do, but M&Ms are delicious, so we'll do it. I keep going. Another day goes by, then it's going to be Friday. And I'm going to divide this in half again, and I'm going to have 6.25 or 6 1/4 M&Ms. So you'll notice the pattern as we're working here. In the time column, we always add. So the T also looks like a plus sign. So your job in this column is to always add. So notice every time we added a day. So from here to here we added 1 day. From here to here we added 1 day. From here to here we added 1 day. And here to here we added 1 day. In the substance column, you always are going to divide by 2. And if it helps you and you want to write that as you work like I did, that's okay. That's a good reminder that you're dividing in that column. So we could keep going because the next question is, when am I going to run out of M&Ms? So let's see if we can keep going on our T-chart. If I add another day, that'll be Saturday. If I divide this in half again, I'm going to start having really small pieces of M&Ms. Let another day go by. divide it in half again, I'm going to have that much. If I have a whole week go by, on Monday, this is less than 1 M&M. So notice that my numbers are getting smaller and smaller and smaller. So to answer this question, what it means, technically, you're never really going to run out of M&Ms. There's always going to be a really, really small piece. The problem is it's only an M&M, and you're just going to say, you know what, forget it, I'm going to eat that M&M. So you're never really going to run out. But on Monday, right here, you have less than 1 M&M. And so if it was me, I would just eat that M&M and be done with my experiment. If you wanted to, you could keep going, and you could just have tinier and tinier pieces of M&Ms, and if that's delicious for you, you go right ahead, okay? So that T-chart is the process that we're going to follow for all of these half-life questions, okay? So the next one we're going to try with an actual radioactive sample. And so when we've got, this one's a little more complicated, we've got some actual numbers here. We like to highlight our numbers. We're looking for times and amounts. This 222 that's in there doesn't really help us, so we're not going to use that. So I'm going to set up my time and my amount of my substance. And let's see if we can fill it in. Time always has to start at 0, so that's the first thing that you're going to put in. So we're going to try to figure out at the beginning of this experiment, how much stuff did I have? And so this says if your original sample contained 120 grams, that means the beginning amount, okay? Next, you have to figure out in the time column. Remember here, you're always going to add numbers. Up here in our previous example, we added 1 day at a time. But this one, it says we have to add a different amount. We have to add whatever the half-life is. It says the half-life is 3.8 days. That's what we're going to add in this time column because that's the half-life that we're given. So if I do 0 plus 3.8, I get 3.8. To figure out the amount over here, I would divide this in half, and after 3.8 days, I would have 60 grams. So if I went another half-life to go by, I would add 3.8 plus 3.8, and it would be 7.6. If I divide my sample in half again, at that time, I would have 30 days. So you could do this all day, but you don't want to. The other number that we haven't used that yet is this 15.2. So let's keep adding up our time until we get to 15.2. So 7.6 plus another half-life of 3.8 is 11.4, plus another one is 15.2. So there's where we want to stop. So let's figure out our grams for that time. So if I have 30, divide it in half, I'll have 15 grams after this 11.4. So another half-life goes by, divide it in half again, I will have 7.5 grams. So how much would we have left is 7.5 grams. If I asked you the number of half-lives, from here to here was 1 half-life, from here to here was 2 half-lives, from here to here that was another half-life, that was 3, and here to here, this whole thing took 4 half-lives to happen. We took our number and we divided it in half 1, 2, 3, 4 times. Alright, let's try another one. So I want to highlight what numbers do I have in here. Here's an amount number for the substance. Here's a time number. Here's a grams number. That's another amount. And let's set up our T-chart. So I have the time and the amount of substance. Okay, time, remember, always has to start at 0, and in this column our job is always to add. Okay, at the beginning I have to figure out how much stuff did I have. It says my original sample had a mass of 64 grams. That's my beginning amount. Okay, it tells me the half-life is 8. So in this time column I'm going to add 8 every single time. Okay, so 0 plus 8, if 1 half-life goes by, it's been 8 days. And the amount of stuff that I have is 32 grams. If another half-life goes by, I do 8 plus 8 is 16. divide this in half again, I will have 16 grams on that day. We're going to stop when we get to 8 grams. So that's going to be something in this amount column. So if I do 16 divided by 2 again, oops, there's the 8 grams. That's the stopping point according to the question. Over here in the time column, 16 plus 8 is 24. So on which day is what we're looking for. It took 24 days for that decay to happen, so that's the answer. If I want to count the half-lives, from here to here that took 1 half-life, here to here took 2, here to here. This happened in a total of 3 half-lives. We divided by 2 3 times. Alright, next question is a little bit tricky, so we're going to try it together. First, find some numbers to deal with. There's an amount of substance, there's a time, there's another time number. We're going to set up our T-chart. Okay, time, remember, always starts at 0, and in this column we are going to add. Okay. In that column, the time that we're going to add, it says the half-life is 8.07 days. So we're going to add 8.07 every time. So let's do that. 0 plus 8.07 is this. If I add 8.07 again, I get 16.14. We're going to keep going until we get to this other time number right here. So keep adding 8.07 every time. That's a 4. Add 8.07 every time. And there's that time number that they were given. So what that means is that we had 1, 2, 3, 4, 5. This process took 5 half-lives. Now let's work with the amount of the substance that we have. This one is a little bit tricky because it says that there are 5 grams left. That doesn't mean that there were 5 grams at the beginning. That means it was 5 grams down here. So when we went down this column, we divided by 2, which means if we want to go backwards, the opposite is multiplying by 2. So let's see if we can do that. So if I do 5 times 2 is 10, times 2 again is 20, times 2 again is 40, times 2 again is 80, and times 2 again, the original amount that we had is right here. It was 160 grams at the beginning. So that one's a little bit tricky because you have to go backwards. Alright, if you feel comfortable with this and you got it, go ahead and keep working. I'm going to work through the rest of the problems. You can check in with me if you need a little bit of help. In this one, I'm going to look for some numbers that I need. Set up our T-chart, time, an amount of substance. Okay, remember time always starts at 0, and in this column we add. The amount that we're going to add, it says the half-life of this sample is 2 days. So we're going to add 2 every time we go down this column. So the first one would be 2, and then 4, and then 6, but we don't know how far we have to go. That's what the gram numbers are going to help with us. So if it decays from this to this one, that means this 54 was the original amount, which means it goes at the top of our T-chart. Oh, that's terrible. Try it again. Okay. So we're going to divide in this column. Okay. So if I divide it once, I get 27.3. Divide it again, 13.65, and we have to keep going until we hit this other number that they mentioned. So if I divide it in half again, I get 6.825, which really, if I rounded it, is 6.83. So that's where we want to end. Okay, so we have our T-chart filled out. The question says how many half-lives happened. So we're just going to count. From here to here was one half-life. From here to here was another half-life. From here to here was another one. So the answer is this took 3 half-lives. Another way to count it is we divided by 2 1, 2, 3 times. So we're counting the half-lives. Alright, number 6 is a little tricky. Find some numbers. Set up your T-chart. Time, amount, so remember, time always starts at 0, and in this one I am going to be adding the half-life that it gives me, which is 8.07. So every time we add, it'll be 8.07. So 0 plus 8.07 is that. We don't know how far we have to go, so let's see what clues we have in the amount column. So if we start with 12.5%, that's the amount of the substance, but it says that that's how much remains, which means that that's what's going to go at the end. So it doesn't give us the starting amount, but percent always means that it's out of 100, right? If you get a perfect score on a test, you got 100%. That means that your starting amount was 100. The clue for that is because it says percent. So now we can go down this column and divide until we get to 12.5. So 100 divided in half is 50. Divided in half again is 25, divided in half again, and we hit the percentage that we were given. So now we know how many times we have to add. So do 8.07 plus 8.07 is 16.14. Add 8.07 again, and we get 24.21. So the question of how long does this take, this is the amount of, this is the amount of time that it took right here at the bottom. So our answer, it took 24.21 days. Alright, see if you can do the last couple problems and then come back and check in with your answers with me. Good luck! Okay, so in this next question, let's find the numbers that we need. So here's a time number, here's an amount of the substance, here's another amount of the substance. So now we can set up our T-chart. So we want the time and the amount of the substance. So remember, time always starts at 0, and in this column we're going to add. And it tells us that the half-life is 164 seconds. So what we're adding over here is 164. So if I did 0 plus 164, it's 164. If I added that again, it's 328, but we don't know how far we have to go. So let's use our amount column to figure that out. So I have two amounts. It said it started with 32 grams of the isotope and it decayed to 2 grams. That means 2 grams happened at the end and the 32 grams was the original amount. So in this column, we're just going to divide by 2. So 32 divided by 2, I have 16 seconds, or 16 grams after one half-life. If I divide it in half again, I get 8. If I divide it in half again, I get 4. And if I divided it in half again, I would get the 2 that I wanted. So now we just figure out, okay, I need a time here and a time here. Remember in that column that you're adding. So 328 plus another 164 is 492. If I add that again, I get 656. So the question says, how many seconds would it take? That's how long it would take. So the answer is 656 seconds. And the second question says, how many half-lives was this? So we're just going to count. From here to here was 1. From here to here is another one. Here to here is another one. And here to here is another one. So altogether, that process took 4 half-lives. That means we divide it in half 1, 2, 3, 4 times. Alright, if I look at this one, let's find some numbers. Here's an amount of the substance. Here's a time number that says days. Here's a time number that says days. So if we set up our T-chart, I want the time. and the amount of the substance. Okay, remember time always starts with 0, and in this column we're going to add. It tells us the half-life is 2.70, and that's what you're going to add. Okay, so 0 plus 2.70 is that. If I added it again, then it would be 5.4, and it looks like we're going to go until we hit 8.10 days. That's the time we want to end at. So 5.4 plus 270 again, that gives me the 8.1 that I want. So now we're just going to figure out the amount of the substance throughout that process. It says how much of this sample is left. That means I started with 100 grams. I want to know how much I ended with down here. So take this 100 and just divide it in half. 50 after this amount. Divide it in half again, you get 25. Divide it in half again. We end with 12.5 grams. That's the answer. If they asked you for half-lives, from here to here was 1, here to here was 2, here to here is 3 half-lives. Alright, let's do this one. Let's find some numbers. And let's set up our t-chart. We want time, and we want the amount of the substance. Time always starts at 0, remember, and in this column we are going to add. It tells us the half-life is 12.4 hours. You're going to add that half-life amount, okay? It looks like we're going to add until we get to this amount of hours. So let's just start adding 12.4. So 0 plus 12.4 is 12.4. If I add 12.4 again, it's 24.8. If I add it again, it's 37.2. Plus 12.4 again is 49.6. Plus 12.4 again, we get our 62 that we wanted. So that means for each of those times, we need to figure out the amount of substance at each point. So it says how much of that sample was left. That means we started with this 750, and we're looking for the amount down here at the end. So you're just going to take that number and divide it in half all the way down. Divide by 2 each time. Divide in half again. Divide in half again. Divide in half one more time. Oops. 4-3 here. Okay, so the question of how much of the sample is left, it is this amount. So our answer is 23.4375 grams. That's how much stuff is left after the decay happens. Alright, last one. Find some numbers. There's some times. Here's another time. Okay, we're going to set up our t-chart. Time, amount of the substance, okay, remember time always starts at 0, and in this column we add. It tells us that the half-life is 138 days, so we're going to add 138 every single time in this column. So 0 plus 138 is 138. The other time number that they give us is 552, so we're going to add until we get to 552. So add 138 again, you get 276. Add 138 again, you get 414. Add 138 again, there's the 552. So we need to figure out the amounts for each of these places. Sometimes it's helpful if you do that. Okay. This one, the grams that we have, it says this many grams are left. That means that that is the amount at the end of the decay. The question says how many grams were in the original sample. That means we don't know the original or starting amount. Remember, to go up, you have to times by 2. It's the opposite. So if I take 12.25 and I times it by 2, it's 24.5. Times 2 again, we get 49. Times 2 again is 98. times 2 again, 196. So here's the answer they were looking for. Our final answer is 196 grams. All right, let me know if you have any questions, and you have a whole nother page so you can practice this on your own. Good luck!